Welcome to another edition of Comet Algebra. I hope you're enjoying your work on your summer packet, and I hope you're having some time to take time and have a little fun this summer and not just do all math all the time. So this edition is section 1.5, applying or using equations. And this is something we're going to be doing all school year long. We will learn about a topic and then we will learn where to use it in real life problems. Because I like to say, if you don't know where you're going to use this math, then why are we learning it? So just a couple reminders from A1. When it's possible and helpful, draw a picture to represent what you are working on in a word problem, and then label the parts of the picture that you know. This is especially helpful when we study trig, but on your packet it can be helpful on the rectangle problems. When you are assigning your variable, I like to remind you that let x equal the thing or the item that you know nothing about. For instance, in a rectangle, if the length is twice the width, well, you know something about the length. It's twice. The thing you know nothing about is the width, so let that be your x, and then your length is 2x. Or if John is half as old as Jennifer, well then you don't know anything about Jennifer's age. Let that be x, and John is x divided by 2. So this is just kind of a helpful thing to remember. The thing in the problem you know nothing about, let that be your x. Another reminder is when you are talking about consecutive numbers. Remember in A1, if x is a number, then the next consecutive one after x is x plus 1. The number after that is x plus 2, and so on. But if you were talking about consecutive odds or evens, then if x is your first number, and if x is assumed to be even, for instance, the next even number after that would have to be x plus 2. The next even number after that would have to be x plus 4, and so on. Just wanted to remind you of that. And then one more reminder that you will find helpful in case you have forgotten from your geometry days. The word complementary means when two angles together add up to 90 degrees. And the word supplementary means when two angles together add up to 180 degrees. Now let's look at a couple examples that hopefully will get your brains rolling again. Example 1. The footprint of the Lincoln Memorial is a rectangle. Determine the memorial's dimensions and the area. So I like to underline things that are helpful in a word problem. So I want to find its dimensions, its length and width, and I want to find its area. And I'm given two pieces of information. I'm given that the perimeter is 620 feet and the length to width ratio is 19 to 12. So in my opinion, a picture would be very helpful in this. Okay, that's my attempt at drawing a rectangle. We're going to pretend like that's perfect. The length to width ratio is 19 to 12. Typically when I think of a triangle, I think that the width is the short side. So if the ratio is 19 to 12, this would be 12 times some factor of x that we don't know, and the length would be 19x. Now we know that its perimeter is 620 feet. And if you recall, perimeter is adding all sides. So if you're that visual, and it's helpful to you to label all four sides so that you can see when I add up all the way around, that's the perimeter. So we want to add 19x plus 12x plus 19x plus 12x, and that would equal the perimeter of 620. Now on your worksheet, I would like to see an equation any picture that you used or anything to help me follow your logic. I do not want a couple answers written down that you got from somewhere that I can't tell. You really do need to show me your work. So then solving this equation, adding like terms, I get 62x equals 620. So therefore x is 10. Now that didn't give me any length or width. I need to just use that x as the factor to get this the correct length and width with these ratios. So 12x for the width would be 120 feet, and the length would be 190 feet. So that's the first part I was asked to find is the dimensions. And the second part I was asked to find is the area, which we know is length times width, and 120 times 190 is 22,800, and area is always in square units, in feet squared. All right, this next example could be a little higher level of difficulty than what's on your summer packet, but let's go through it, and I think the information will be helpful. So this is an interest problem, simple interest, and in this problem, the interest is calculated annually. Now that's not really how it's done in real life, and we'll talk about that more later in the school year. But for right now, the formula for simple interest is the principal, which is the money you start with, times the rate. The percent would need to be changed to a decimal before we multiply, times the time in years. So we're going to use this formula to see how much this guy, if he makes this in interest, $904.50 every year, he has $9,500 invested, but it's in two different accounts. One pays 9% interest, and the other pays 10.5% interest. Okay, why he doesn't put all his money in the higher interest account, I don't know, but here we go. So we have two different interests we need to add together. So I'm just going to kind of make a note to myself. I want to take the 9% interest, and I want to add that to the 10.5% interest. And when I add those two together, that's where the 904.50 comes from. So this is kind of just going to give me a little framework, if you will, to follow. So I need to algebraically express these two interests, and then if I add them together, I'll get the 904.50. So I do not know how much is in each account, so we need to let x equal one of these, and it's random. I'm just going to let x equal the money that he has in his 9% account. And all I know is that together he's got $9,500 invested. So however much money is in this account, I would have to subtract from this $9,500 minus x, and that is then how much money he has in his 10.5% account. So at least now I have the principal expressed algebraically. I know the rate for each account, and the time they have said annually, so it's just in 1 year. So now continuing with the PRT formula. The principal in the 9% is x, and the interest rate is 9%. So I need to change that percent to a decimal, 0.09 times the principal is x, and the time is 1 year, so there's a 1 in there. So I have 0.09x. I need to add to that the interest in the 10.5% account, again changing that to a percent, 0.105 times this, the amount of money in the account, 9,500 minus x, and these two accounts interests added together, he gets $904.50 a year. So now we need to solve this equation for x. So doing the distribution first, we distribute the 0.105 and we get this equation. So the next thing we do, of course, is combine like terms. So after we combine the x terms and then subtract the 997.5 from both sides, we get this equation. And at first it might concern you about the negatives, but they just divide away. So if we divide both sides by negative 0.015, I get x equals 6,200. So now we know that's how much money was invested at 9%, 6,200 at the 9%. And so then if we just subtract from 9,500, we end up with $3,300 at the 10.5%. All right, so now I hope you are comfortable using the simple interest, the PRT formula. Show your work, write your equations, label your answers with units, and have fun with the 1.5 section of your summer packet.